Okay, here we go. Last topic on heat transfer, and this would be heat transfer by infrared radiation, or IR for short. It's also known as IR. Alright, so what is this? Basically, this is one aspect of the electromagnetic spectrum. We will be studying the electromagnetic spectrum in more detail later when we talk about waves and light. Alright, but just know for now, what you can see when you look at things, those colors are in the electromagnetic spectrum, but they're only a tiny part. See right there? This is like the electromagnetic spectrum visually laid out according to wavelengths. Visible light is only a small portion of that. And then to the right of visible light, you have the infrared spectrum. All right, so the infrared part of the spectrum. That's the part of the spectrum that we're concerned with in this video. All right, this is infrared radiation. It carries heat. All right, so this is just to orient you as to what is IR, and that's basically what it is. It is a form of electromagnetic radiation. It's on the EM spectrum, electromagnetic spectrum. All right, so infrared radiation is the part of the EM spectrum that transfers heat energy. All right, in order for infrared radiation to travel from one place to another, it does not require a medium. It can travel through a vacuum. In fact, that's how heat gets to us from the sun. It travels through the vacuum of space where there is no air, and it heats up the Earth when the Earth absorbs that radiation. Okay? What you see here is a thermal image, which I'll explain in a minute. First, let's talk about what we say here at the bottom. Every object emits infrared radiation in all directions. So I'm emitting infrared radiation as I'm talking. You're emitting it as you're listening. The computer you're watching this on is emitting, or if you're watching it on a smartphone or a tablet or whatever, that's all emitting infrared radiation, all of it. Everything emits infrared radiation in all directions. However, hot objects emit more. So hotter objects emit more infrared than cool objects. And you can then use a cool camera to see, quote unquote, see the infrared spectrum instead of the visible spectrum, and then it can translate the amount of infrared that it detects into a color. So this isn't actually a picture, a visual picture. This is a picture of a thermal image of a steam engine, basically a train engine. Okay, this is a working train engine. You can see it's really orange and yellow and red in here and white, right? So on the thermal image, that all means it's hot. All right, it's not actually that color. If we took a normal picture of this thing, it would probably be mostly metal, and it would look like most train engines you've ever seen in your life. But this is a thermal image, and it has taken the infrared data, the IR information, the amount of infrared being absorbed by the camera, right, being emitted by the train, and it's translating that into colors, basically, that we can see. We cannot see this infrared, but the camera can, and then it can translate the infrared into colors that we can see. Cool! So you can tell this part of the engine's hot. The rest of the surroundings are relatively cool compared to that. Alright, so infrared can be emitted, and absorbed by objects, right? We talked about that already. Interestingly enough, does the color of the object matter as to how well it emits and absorbs infrared radiation? Oddly enough, it does matter, all right? As it turns out. The details of that are beyond what we need to talk about in this course, but you're going to need to know dark colors, black especially, are very good emitters and absorbers of infrared radiation, and white or light colors are very bad emitters and absorbers of infrared radiation. Bad. All right, so what does that mean for you? Well, if you're designing something that you want to absorb a lot of heat, then you should make it dark colored. If you're designing something that you do not want to absorb heat, you want it to reflect and reflect the heat and stay cool, then you would want it to be white or another light color. All right. So as a side note, how could you apply this in your everyday life? Well, if it's going to be a hot sunny day and you're going to be out running around in the sun, possibly you should choose a light colored shirt because that is going to absorb less of the sun's radiation. Dark colored shirt, it's going to get hotter. Have you ever felt like you're hotter in this dark shirt and you're like, oh, I'm so hot, and your friends are like, it's not that bad, and they're wearing white shirts? Guess what? You are hotter than they are, right? Because you've got this dark shirt on. It gets hotter than their light colored shirts. That's real. That's not imaginary, all right? You actually are getting more absorption of the infrared radiation from the sun because you're wearing a darker color, and therefore you're going to get hotter and you're going to sweat more than your friends who planned ahead and wore a light colored shirt. All right, so learn your lesson. All right, anyways, I'm being silly. Okay, anyways, white reflects infrared radiation, and it is a bad emitter of infrared radiation. Black is a good absorber and a good emitter of infrared radiation. All right, and just to summarize that, we have that right here. Dark colors absorb and emit IR much better than light colors. Okay, so let's summarize what we have covered in these 3 videos about heat transfer. First, conduction. What's the heat transfer method? In this column, we're going to show you the heat transfer method, and then we're going to tell you how it can happen. All right, so conduction happens in solids, liquids, or gases, requires a medium, some kind of material. It has to have matter, atoms, molecules, that kind of thing. It has to be transmitted through that, and it's usually solids. All right, convection. Convection occurs in liquids and gases only. Only ever in liquids and gases. It cannot happen in solids. It does require also matter, but it requires matter in the form of liquid or gases, which are known as fluids. All right, so it has to happen in fluids. It cannot happen in solids. It cannot happen in a vacuum. Now, radiation, IR, which we were talking about in this video, it can happen in a vacuum. It does not need a medium. Interestingly enough, infrared cannot pass through solids. It can pass through gases as long as they are transparent. It can pass through liquids if they are transparent, and it could pass through solids if they are transparent. So glass, it could pass through glass. It could pass through some plastics. All right, but basically, infrared radiation travels through a vacuum or a transparent medium. It will not pass through something that is not transparent. All right, it has to be transparent. If it's a solid that is not glass or plastic, you can't see through it, then neither can the infrared radiation get through that. All right, it has to only travel through things that are transparent or a vacuum. All right, so that is the summary of what we learned about heat transfer methods. That's all I've got for you for now, and we'll catch you in the next video. Pretty much this sums up what we're talking about for heat transfer. So not only does this wrap up these topics, it wraps up thermal physics. So that's pretty cool. Anyway, double sign off this time. Catch you next time.